So we are going to start the session for data analytics. So you see here on the upper half of this slide, there are various tools and softwares, and some streams are showing over there like statistics, artificial intelligence, machine learning, deep learning, data science, and data analytics. So this all different terminology I will explain one by one. And there are various tools and programming languages like R, Advanced Excel, Python, Tableau, SAS, SPSS, MySQL, Hadoop, Power BI. So these are all the tools which helps us in the data analytics, so machine learning, data science, deep learning. This all. In the lower part, you will see there are 4 types of analysis we perform. Here in this data analytics course, we will perform only 3. Okay, 4th one is for the data science, which is the artificial intelligence, prescriptive analysis or the perspective analysis. So first is the descriptive analysis, inferential analysis, and predictive analysis. We'll cover this. Up to machine learning, we will cover here. And in the prescriptive analysis, we have to go with the deep learning and artificial intelligence in deep learning. So here we will learn about the univariate analysis, data visualization, data manipulation, how to manipulate the data, correlation analysis, hypothesis testing, a priori, k-means, nearest network, k-nearest neighbors, linear regression model, logistic regression model, decision tree, random forest, support vector machine. These are all the machine learning algorithm. Naive Bayes algorithm, principal component analysis, hierarchical clustering, extreme Bush gradient. These all algorithm we will learn, and these all sort of analysis, the data, univariate analysis, data visualization, these all activity we will do. Later on, we have some sentiment analysis. We apply some of this algorithm over there. Churning analysis in the telecom industry, meta analysis in the inferential part. Pandemic analysis, market basket analysis, customer segments, etc. We will perform this. Now, you will see here, I am going to differentiate the statistics, data analysis, and data science. The core of data analytics is statistics and mathematics. Okay. More is the statistics. Mathematics is a very smart part, small part in data analytics, but in data science, there is a big ratio of mathematics. So if we see the generic definition of statistics, it is a science and art of collecting, classifying, computing, analyzing, interpreting, and presentation of data and its insights. So it is science and art both. We collect the data through various sources, and we classify the data. Data classification is very, very important. And then we compute the statistics, whatever the mean, mode, median, standard deviation, any sort of statistics we compute through these. And we got some result, and in the numeric format mostly. And we analyze it later on. And after analyzing, we interpret in some word statement. And finally, we present our result with interpretation in the form of table, graph, statements. Okay, so this is the whole process. This is the statistics basically. And here you see it is science and art both. So I would like to explain why it is science and why it is an art. I think that I have already covered these in our Davos session. I don't know, but I will repeat this again if somebody is new to understand the thing. You see here we have a very small data set, or we have to find out the mean. So I would like to please do some exercise to find it out for me. What is the mean of this data?
8.
8. Anyone else?
It's 8.
8. Okay. 1 and 3, you are also right. Prerna?
8. Sangeeta,
8.
3.
Selu?
8 only.
8. And Sangeeta?
For 8.
8. So all you are getting the same mean? There is no difference in the mean of anyone? And I also say it is 8. So we are getting the uniform result. No? So in the science, you always get the uniform result because we are using some mathematical technique or the formula or the method by which we are going to find out the mean. So there is some mathematical formula or method. So we are getting all the same result. So it is a science. It doesn't mean that I am more experienced than you. My mean would be better than you. Is it possible? No. So therefore it is a science. Like in chemistry, if you mix the acid and base, you will always get the salt and water. Nobody could get the alcohol out of it. So same thing is here. If we don't make any calculation mistake, we all get the same result. Okay, so it is a science. Now the second thing, why it is an art? So look at here, it is a glass of water. How do we interpret this? Yes.
Earlier you told us it is filled. Half glass of water, half glass of air.
Yeah, you attended that
Yeah.
demo. I explained it. Okay,
Yes, sir.
okay. Yes, yes. So I, in spite of that, I explained that some people says it is half empty, and generally in the first sort, and some says that it is half filled. Okay, generally this interpretation mostly comes in the first sort. But the correct interpretation would be this glass is full half with water and half with air. Okay, this is the air and water. So this would be the correct interpretation, or this interpretation requires some experience. Whenever you get some value through the result after the computation of the statistics, you have to interpret that value. And the interpretation is an art. Okay. So how well you interpret it, that is the thing. As you know that in the case of Prashant Kishore, do you know the Prashant Kishore? Yes.
He's a political analyst,
Yeah.
strategist.
So first he joined the BJP. Okay, I was also in the IT cell of the BJP in data analytics. So his interpretation was very good, due to which Mr. Modi offered him to join the BJP. Okay, BJP IT cell parallel. So that was the interpretation is very, very important. Whatever the figure he got, he interpret in very well manner. Okay, that is the quality of Prashant Kishore. Okay, analysis is a good thing. It is being done by the team. Okay, but the interpretation is done by the Prashant Kishore of the whatever the analytics the team is doing. So that is the thing. So sorry. Now we come. So we understand what is statistics. Now, what we are going to study is the data analytics. What is data analysis? So it is a process of inspecting, cleansing, transforming, and modeling data with goal of discovering useful information, informing conclusion, and supporting decision making. So data analysis is a process, and it is not a science and art of inspecting the data. How you would inspect the data, as I explained you in the demo, how we inspect the data. We take a glimpse of data, then we see the structure of data, and these all things. So in this way, we could inspect the data. And then if there are some gangs and some abusing in the data, then we clean it. We clean the data and we transform the data as per our requirement, row and columns, whatever. And finally, we model the data. We train the data. We do the machine learning, whatever activity, with the goal of discovering useful information. Okay. Informing conclusion and supporting, which support us in decision making. Okay, that is the data analysis. Third thing is data science is an umbrella term that encompasses data analytics, data mining, machine learning, and several other related disciplines. So that is data science. It has everything. So data science is an interdisciplinary field, uses scientific methods, processes, algorithm, and system to extract knowledge and insights. Okay, it is interdisciplinary field that uses scientific methods, whatever we have, and processes. Okay, the data analysis is a process, algorithm, okay, and systems to extract knowledge and insights for many structured and unstructured data. Okay, data science is related to data mining, machine learning, and big data. All. So this is data science is an umbrella term. Now, at the last, you see there is one question. What is first statistics? Yes, can somebody tell me? Yes.
The mean median mode.
And these are the statistics, but the first statistics. Yes, anybody else? Yes, try. I want to be this class interactive. So if you participate, it will be better.
Is it something like the initial assessment?
Assessment is okay, but the statistics like mean, mode, median. What is the first statistics? I give you some hint.
Um,
If you have a categorical data, okay, like suppose in this workshop, Prerna and Sangeeta and Selu is I don't know. There are some male and female. Okay. So in a group, suppose if I say there are 42 females in a group, is it a complete information I am getting out of that?
No, sir.
No.
If I explain this in a percentage, suppose if I say there are 48% females in the group, then is it complete now?
Yes, sir.
Okay.
Yeah, sounds.
So it is giving them some insights of the data. The first was not given. So what we have used here for, instead of frequency, what we have used here?
Percentage.
Percentage. Oh, percentage is was. Percentage is nothing. It is just the proportion multiplied by 100%. Does that make sense to you? Proportion. And proportion is what? Proportion is the probability. Favorable outcome over total outcome. Does that make sense to you now? So we multiply the probability with 100%. Okay. Proportion and probability. Probability we use for the expectation. And the proportion is we use for the certainty. Does that make sense to you? The thing is same. What it? The formula is same for the proportion and the probability. I explained. Probability is equal to favorable outcome over total outcome. This is also the proportion. Formula is same for the proportion if you find out the proportion of something. So multiply this by 100%. So that is called the percentage. Okay, so the first statistics is probability. Got it? First statistics is the probability. Is there any doubt now?
No, sir.
And the last statistics is also probability. It means statistics starts with probability and ends with probability. So why it is last statistics is probability? You will understand later on in better manner, but I just explain you here. Do you know the hypothesis testing, some of you? Yeah. Inference and analysis, t-test, g-test.
No, sir.
Okay. So I give you some other example. In the machine learning part, in the predictive analysis, I explain where we end with. Suppose I am making a chatbot. You know the chatbot is I used being in the most of the mobile application app of banking. And there is a chatbot. You ask something and it replies. So in chatbot, there are two engines, two models we use of machine learning. One is the user interface model. Second is the dialogue management model. Okay. So what is the work of user interface model? User interface model, whatever the text you write, it decomposes the text. Okay. And find out the intention of that text along with the entities. So what is the intention of this statement? It just sort out that. So we have already fed so many intentions over there in the model. Some keywords are there. We have put, if this keyword you find, it means it is that intention. If this keyword is like that. So there are thousands of intentions. And if we are inquiring something, so my text would be different and your text would be different, but we are inquiring the same thing. Our intention is same. Am I right?
Yes, sir.
And we have a different text and we always talk in a different way, but the same thing. So text would be different, but intention would be same. If we are making some complaint, So our intention is complaining, but our text or the statement would be different. So what does it do? That machine learning model, when the text goes in that model, it find out the intention. What is your intention? And how he got the correct intention? It's find out the probability of the intentions, different intentions. The complaint probability is 86.86, and inform intent probability is 0.43, and request probability is 0.22. So whatever the highest probability, that it finalize that intent and send it to dialog management model. Transfer this intent to dialog management model. In this intent, and some entity is also there. I will not discuss here about the entity. And it transfer it to dialog management model, and that dialog management model, as per that, there are so many templates. This time, no chatbot is a AI. They say that our chatbot is AI. No, there are contextual chatbot. It is 50% AI and 50% it is not AI. So in the first model is AI, where we find out the intent. And the second model where we respond is not a AI. We have already fed few templates of all the intent. With one intent, we have written four answers. It randomly choose one and reply. There are already answer is there. So that is not a AI chatbot. They are all up to now. All chatbots are contextual chatbot. The AI chatbot will come after coming the 5G everywhere. We could perform through the machine because there is some algorithm. There is an NLP which we use on the first model, but in the second model we don't have any algorithm which could join the words and make a sentence. We could divide a sentence into word, and we could remove the white noise from the sentence, like the prepositions and our conjunction. These all we could remove it, and then the meaningful words remain over there. Noun, adjective, these all, and as per that we find out the intent. But we could not join the words and make a sentence. This process is not, we don't have any algorithm or any technique for that. So the people are doing work on that. It will come near it for any time, and then we could apply this. At that moment, it would be a complete AI. Like Sophia, you have seen the Sophia robot. It also came in Indore. And I also went over there in particular. So I asked them, I want to ask some question. So they denied it. Nobody could ask the question. Because they know that if I ask the question, so उनका पोल खुल जाएगा कि नहीं यार ये complete AI नहीं है. There are already few templates. So they have the written question and they have asked those questions, and the Sophia was replying that. So I understand that it is a contextual, it is not AI, complete AI. Okay. They are making fool world. So we have AI robot. No, that is not AI robot. In future it may be. So you understand the statistics end with probability, because we decide the everything as the probability. Have you seen the Terminator picture film? So in the Terminator field, that Terminator always see the percentage. Whenever you see anybody and you see on the screen the written that the percentage of being male is 86. This whole thing is written over here. So percentage is the probability, because they in the movie they use the percentage. They could not say the probability because the person don't know what is probability, but they know the percentage. They use the percentage. You will watch the movie and you will see the, I'm not always say this percent probability, this percent, this is not the, this percent chance. He always tell this thing. So that is the probability. So the statistics end with the probability. Now, there are so many things we'll perform. One thing is the data exploration. We explore the data. Whenever we have a data set, we read the data and we try to understand the data. We do the univariate analysis, bivariate analysis. So we explore the data. Without explore the data, we could not do the analysis. I'm just explaining little by little, not the in detail, the process. Second is the data wrangling. Data wrangling is we have to discover the data from where we could get the data and structure the data, clean it, enriching it, publishing it. Data wrangling. Wrangling is from searching out the data and the up to the publishing. Okay, publishing means the data which we could now use for what? Analysis. That is the publishing. That is not the final publishing. We are not publishing the result. We are publishing the data. Okay. Then data mining. This is my favorite one. We do the data analysis. Sometimes we have some objective. Most of the time we have the objective. Why we are doing the data analysis. But sometimes we have the data, we don't have any objective. And then at that moment, we have to deep dive in the data. And we have to find out the insights, useful insights from the data, patterns and these all things. So that is data mining. So I like that thing without any objective. You deep dive in the data, you find out the precious stones from the data. Will not go in detail. Later on we will go in detail, otherwise you will get some बोर होने लगेंगे आप लोग ज्यादा डिटेल में जाऊंगा मैं खाली आपको हर टर्मिनोलॉजी का मीनिंग बता रहा हूँ जो हम यूज करते हैं. Data warehousing. We got data from various data sources in a company, like through the ERP you are getting the operational database from some other source. The external source is also there, and these all data we keep in data warehouse, like the storage warehouse, that the warehouse we use in the for the grain, and these all the same thing is here. We put our data in the data warehouse in a particular structure, and from there we could fetch that data and we could work on that. Okay, so that is the thing. Data warehouse we use. So we will explain in detail later on about these all things. I am just giving you such one glimpse of this all. Now, as I explained you in the starting, we have 4 types of analysis. One is the descriptive analysis. Second is the inferential analysis. Third one is the predictive analysis. Fourth one is the perspective analysis. Perspective analysis also called prescriptive analysis. So I write here prescriptive. It would be understandable prescription. So prescriptive analysis. So descriptive analysis is what? What is whatever you have in the data is called a descriptive analysis. This means how many males are there, how many females are there. Okay. And what is the mean marks of the students of section A? What is the mean marks of the student of the section B? These all statistics, the mean, mode, median, standard deviation, these are all comes under descriptive analysis. Okay, correlation analysis. And inference analysis, why it is? Okay, why it is? We use the hypothesis testing, why there is significant difference in the marks of mathematics in the section A and section B students. So that is inference analysis. It is the study of cause and effect. Okay. Then predictive analysis. What will be? It means, suppose we have a data of crop production of last 50 years, and I trained a model which predict the crop production as per the rain. If you impute the figure of rain, it will give you the crop production. That is the predictive analysis. What will be? Later on, there is prescriptive analysis. So what should be? There are not only the rain, which is which only make some impact on the crop production. There are some other factors also, like the sunlight, soil quality, seed quality, fertilizers, pesticides, irrigation. These all factors also impact on the crop production. So at that moment, if you want, if your model is giving there would be X metric ton crop production, if you imputing these all variables value, and but there is a demand of Y metric ton, which is very higher than the supply. Then your artificial intelligence model, prescriptive model, recommend you as per the soil quality. It recommend you the fertilizer. This fertilizer you use this in this quantity. Okay. As per the sunlight, it recommend you the irrigation. Okay. How many times you have to water the field? As per the disease, it suggests you the pesticides. So this is the reverse process basically. It is suggesting you are not imputing that thing. It is recommending you do this thing. Then your production may increase. And you could minimize the gap between supply and demand. So that is the prescriptive. It is giving us the prescription. Okay, recommendation. So the prescription it is giving us. So that is the thing. So I think, is there any doubt up to now we have read?
No, sir, it's going pretty fine.
Just a moment. I just take the milk. दूध वाला आया है milk में. So Hi Ritya ji, how are you?
फाइन सर फाइन थैंक यू
आप ही लेट हो गए हैं ना, आज हमारे कैप्टन ही
हाँ।
लेट आए।
अब हाँ सर
मैंने कहा कैप्टन लेट हो गए।
सर हाँ आज फर्स्ट डे सर अभी टाइम लगेगा बट आ जाएंगे टाइम पे
चलिए ठीक। चलिए हम स्टार्ट करें, कंटिन्यू करेंगे। इतना समझ में आ गया ना आप लोगों को? क्लियर हुआ?
हाँ जी।
अब हम अपना कोर्स चालू करते हैं। फर्स्ट वी स्टार्ट विथ क्लासिफिकेशंस ऑफ डेटा। ओके, let me share my screen with you. So let's we see about the there are various classification of data, but we don't go in all. We have some hybrid classification which we use here. Okay, so we have divide the data for data analytics and the data science into parts. One is categorical data and second is numeric data. Okay, as a categorical data, suppose you have a column like gender. Here are the categories, male and female. Whatever the categorical data, it is always in a strings. These are called the string. If we put in the quotes in the programming language, in the single quotes or the double quotes, doesn't matter. Suppose you have name of cities column like Mumbai, Delhi. Now in this way you have Pune. This in this way have the name of cities. So this is also categorical. We could have some attribute also like the hair color. So it may be white, it may be black, it may be brown, it may be golden, it may be silver. Okay, so these the here. These are all the categorical data. Numeric data, we have three types of numeric data. First one is ordinal data. second is the binary data, and third one is the scale data. In scale data, we again have two classifications. One is the interval, second is the ratio. We could say that I make one more thing. Said the discrete and continuous first. In continuous, we have again interval and ratio. So this is the our hybrid classification, and first I will talk about the ordinal data. What is ordinal data? Ordinal data. There is order, but there is no fixed interval between two consecutive orders. Okay. If you see, generally we use the Likert type scale. And some of you know about the Likert type scale, I don't know. There are Likert type scales from 3 points to 10 points Likert type scale generally we used. Okay. Here I am taking one example of 5 points Likert type scale and the scale of agreeableness. There is a scale of satisfaction, a scale of importance. There are so many scales. If you search on the internet. So here I write the different categories of that 5 points scale. Strongly disagree, disagree, not certain, agree, and strongly. I am also giving few orders. 1, 2, 3, 4, and 5. But these are the orders. Here, what I want to say that the difference between 1 and 2 and the difference between 2 and 3 is not same. It is always fluctuate. So if there is no fixed interval between two consecutive order, so it is not a scale. A scale always has a common difference. Okay, like if we take a scale we see in the centimeter. So between 0 and 1, whatever the difference, the distance, same distance you will get between 1 and 2. Same between 2 and 3, then 3 and 4. Does that make sense to you now? Yes.
Yes, sir.
If any single point you get some confusion, you may ask. Don't hesitate to ask anything. If it is minor, you ask.
I have one query. Likert means different types of opinions.
What?
Likert scale, Likert test scale.
Ah,
What
Likert
is
type.
it? Meaning of Likert means different kinds of opinion.
It is for the liking. Taken the word is take from the liking. Likert type. It is not a Likert scale. Type scale, because ordinal data is not a scale data. Okay, so we use the Likert type scale. So it is generally called the ordinal scale. We Likert, what you are liking. We are giving you some option what you like. Out of this, you have to like anyone. Na? Strongly disagree in the some contest. You are disagree, not certain.
Okay. Okay.
So you will be giving us this, I mean, the copy, or we should note it down, like, what are you writing?
Okay, I will share the
Okay.
link of the recording.
Done. Done.
Okay, and I will also give one copy. I have already PPTs. Okay, I will share with you in the PDF format. I have the PPTs. Okay. So if I give one example why this difference is not same. Suppose there is a company XYZ. XYZ is a company where 3 employees working on the same post. Mr. A, Mr. B, and Mr. C on the same post. And management decided to give them increment of rupees 3,000 in their monthly salary. This increment. But all the employees, Mr. A, Mr. B, and Mr. C, are strongly disagree with this amount. Then management decided to give them more rupees 2,000 additional in the increment. Now the increment is 5,000. Now we see where they switched from strongly disagree with this additional 2,000. Okay. Strongly disagree, not certain. And I do in a different way. Do it better. This is my scale I make here. This is my scale. This is 0. Suppose it is 500. It is 1,000. This is 1,500. And this is 2,000. Okay. This is a scale. The salary is on a scale. Rupees always in on a scale. We get the same difference. Now I talk about the Mr. A. Mr. A, after getting this 2,000, he was he was strongly disagreeing. Okay, and then after getting 2,000, he is strongly agree. He was strongly disagree, and this is about the Mr. A. And Mr. B, who was also strongly disagree, now he is at not certain. Sorry, we'll take the whole. He was strongly disagree at an initial stage. Now with this additional 2,000, he just switched to not certain. Okay, so we know that not certain is 3. I will put the numbers later on, and it is the Mr. B, and Mr. C. if we see with the same amount, it is just decided. So if you see here, Mr. A from 1 to 5, Mr. B 1 to 3, Mr. C 1 to 2. So Mr. A with the same amount 2000 rupees, you see here it is 2000 rupees. For Mr. B this is 2000. For Mr. C this is 2000. So there is no fixed interval. Got it? Between the orders. Any doubt here?
No.
Hi Sabya. How are you?
Hello, sir. Sorry for the joining late.
No problem. It was the first day. So आज punishment नहीं दूंगा, बाहर नहीं खड़ा कर रहा हूँ.
आज मुंह दिखाने कभी भी नहीं.
अपना कैप्टन अपना मॉनिटर भी लेट आए ना आज, रित्या भी लेट आई.
अब थोड़ा कम बुरा लगा.
हाँ मॉनिटर भी लेट थे, क्या बोल सकते हैं. मॉनिटर ही लेट आ रहा है तो क्या बोलेंगे दूसरे स्टूडेंट्स हैं. So you understand what is the ordinal, why I am telling that there is no fixed interval. Now you got this? Any
Yes, sir.
doubt? No. So this is the ordinal data. Why we are learning that the numeric data, ordinal data, whenever we have the ordinal data, we in the further analysis, we go with the median, not with the mean. And a mean, if we take the mean of this ordinal data, we may get the mean somewhere in the decimal. Suppose you could get the mean 2.1. We could get the mean in the decimal format. Then what will happen? Because there is no fixed interval. If there is fixed interval, then you could write that 0, 1, and 2, and 3. So if this is fixed interval, then you could write the 2.1 would be here. But in the ordinal scale, there is no fixed interval. So you could not put this value anywhere between 2 and 3 order. Does that make sense to you?
Sir.
Okay. So whenever we have ordinal data, we use the median in the further analysis. Okay. So second is the binary in the numeric. Binary data. Binary data we have in 0 and 1 only. And just like we could say the yes and no, we could say the true and false. Some other also, male and female, black and white. Wherever we have the dichotomous, two categories only there. Okay. Okay. Positive and negative. These are all binary data. And we generally represent by 0 and 1. Generally in default, we present yes by 1 and this by 0, this 1, 0. Here also positive 1, negative 0. But here, if you see in the male and female, either you could put male 1 and female 0, or you could put female 1 and male 0. Similarly here in the black and white. So whenever we have a column like gender, we have a category male and female. Then we convert them in dummy variable. The gender, instead of gender, we take either male or female, anyone, not both. Or that is called as dummy variable, or that is only k minus 1. K means how many categories we have. We have the 2 categories, so 2 minus 1. So we have the 1 dummy variable. Either we could choose male or we could choose female. Suppose we are using the male. Okay. And we have like the, I also write here female and then male. In this way we have the data. Okay. So in the male it will 1, female it will 0. Got it? If I take the male. And if I take the female as a dummy variable, then first one is male, but we are taking the female column. So it would be 0. The female would be 1 here. Does that make sense to you? Any doubt?
Yes, okay.
Okay. So this is the binary data. Sometimes we have to convert the categorical data in binary data. Okay. As you see here also in the Stokely disagree, these are all the categories. Basically, we convert them in an ordinal form, order form, ordinal data. Here, these categories we are converting in binary format. Does that make sense to you? Now, scale data. Scale data, first I will explain you about the discrete and continuous. Okay, and interval and ratio. These are mixed. So first I explain you discrete and continuous. What is discrete data? What is continuous data? It depends on the unique values. Okay. Suppose we are conducting some survey for UNICEF in Mumbai, in different areas like Kandivali, Vilepalle, Mira Road, whatever. And we are just taking randomly 100 families. And we are asking them how many children are there less than 5 years age. This survey we are conducting because we have to send the demand for the polio drops. Okay. Which is being given to the children age less than 5 years. So randomly we are 100 families we are selecting in a Mira Road, 100 families we are selecting from Daisar, we are selecting from Kandivali, we are selecting from Vilepalle. This, so we could get the average, and as per the we could find out the what would be the population, and how would be, how many children would be there if we know the number of families. This much may be there because the number of families could be get through the municipal corporation, that figure. Even in that area, how many families are there, or the electricity board we could get that data. We have a various approach to collect the data, to gather the data. Suppose we see the first family we went and we see there is no children less than 5 years. Second family, there are 2 children, then 1 children, then no children, then 2 children, then 3 children, then 2 children, then 4 children. Then no, then 1, 2, 2, 3, 4. And in this way, we are getting this data. Number of children. less than 5 years. Okay. In this way, we are getting 100 families. And then we see the how many unique values are there. So we get there the unique values 0 children, 1 children, 2 children, 3, maximum 4 children we are getting less than 5 years in a family. So we have taken the survey of 100 families and we are just getting the 5 unique values. So there are, it means very few unique values we are getting. So this sort of data is called the discrete data. Got it? The very few unique values. Very few unique values. Suppose you are also measuring the weight of the children which are less than 5 years. Okay. So there are the children from 0 years to 5 years, children of 3 months, children of 2 months, children of 5 months, 8 months. So there may be difference in the weight, maybe 2 kg, 2.1, 18 kg, up to 5 years. There is 17.5. And this way we will get so many unique values. Huh? There are many unique values. So it is a continuous data. Does that make sense to you? Is it clear? Suppose there are, we have got the children less than 5 years in the 100 families, total 100 families, we have got 135 children less than 5 years because some family has 3 or 4 children, some has no children. So out of these 135, we are getting 80 unique values, different unique values. Is it clear? So this is the continuous data. So why we are making this classification discrete and continuous? Because this, it depends on the nature of the variable. If you get a continuous discrete data, either you could convert them in categorical format or you could use it as a numeric value. So it depends on the nature of your variable. So I explain it that also. Now we come to the scale data where I explain this thing also. You see in the continuous we are getting the interval and ratio. Okay. Interval and ratio. What is difference between these two type of data? There is a difference of 0. Difference of 0. We have two types of 0. One is pseudo 0. Second is real 0. What is pseudo 0? If I talk about the temperature and I write the temperature in degrees Celsius, and if I say that there is 0 degrees Celsius temperature, what does it mean? There is no temperature. What do you say? Yes. There is no temperature.
There is temperature.
There is temperature.
The value of temperature.
There is temperature. It is not a real 0. It is a pseudo zero because there is some temperature, still it is telling zero. Zero means no. If I talk about the marks of the students, if I say the zero mark, what does it mean? There is some marks or no marks?
That is real zero.
There is no marks. It is real zero. So real zero has some property. If you multiply the real zero with any number, it will make zero. If we divide any number by zero, we will get infinite. Does that make sense to you?
Yeah.
But in pseudo zero does not possess these qualities. Suppose you have a data like -2. These are the degree Celsius. Temperature in degree Celsius. -1.7, 0, 2.3, 3.7. In this way, you have this data. This is the data of temperature. There is a data of pressure also. I don't know about the pressure and this all. The unit is Pascal or what. I'm just writing some number hypothetically. 57214. And we are doing some mathematical operation in the analysis part. So suppose we are multiplying this. So it is okay, it is -10. Okay, this is 7, 1.14. No? 11.14.
11.
11.4. This
11.9, sir.
749, sorry. It is okay, 2.3. It is whatever. But it would be zero or not? Is it possible? This is not possible. Because this zero is not real. It doesn't possess those quality of real zero. What it? Does that make sense to you? Because this zero is pseudo zero. So it will not make the result zero. It don't have that quality. Does that make sense to everyone? Yes. So whenever you have this sort of zero, in this sort of physical quantity, you are having the pseudo zero, then you could not perform this multiplication activity with zero or the division activity with zero. Then what we have to do with this sort of zero? What is the treatment of this? Suppose you have a very few values, means it is a discrete data. Suppose it is a discrete data. We have only 5 values are repeating again and again, the same value. Okay. Then what we will do, we will convert them in strings in the category. So what we do, we just make them -2, one column, second column -1.7. It is the category. So we are making the dummy variables. So out of 5, we will make the 4 dummy variables. Any 4. Not taking 3.7. N minus k minus 1 dummy variable we have to take. If the somewhere temperature is -2, then it will burn, otherwise 0. In the observation, you have the temperature, suppose here -2, then -3.7, so sorry, 3.7. Okay. Then 0, and then 1 -1.7, then -2, in this way. So what will happen? You will write in this way. Here you will write in the 1.7, -1.7, here 0, here 0, here 0, here 1, 0. In the 0, you will write 0, 0, 1, 0, 0. What it? Does that make sense to you? Is there any doubt?
So what are we doing? We are creating a matrix out of this.
This matrix. If we are taking the binary number and a binary 0 and 1.
Giving
So
the
we are
example.
making the dummy variables. We are converting this number numeric in a categorical format. So these are now categories. These are now category, not a number. So we could make a dummy variable with the category. If we have the very small few categories, okay, few unique numbers, then we convert them in category in this way, and we make the dummy variables. So it would be k minus 1. So how many categories? 1, 2, 3, 4, 5. We have the 5 categories here. So we have just make 4 dummy variables maximum. So one, then in this way we make the data.
I have a question here.
Yes.
So when we are saying k minus 1, so is it up to us to select whichever the data or whichever the
Okay.
values are there?
Which we have to drop, na? Which category we have to drop? You want to ask that too?
Yes.
It's
So
up to us.
how
It's up.
should-
There is no fixed rule. Okay.
Okay.
Generally, what we do, whichever the low frequency, we drop that one. Generally, but it's
Okay.
not a rule. It is not a fixed rule.
Okay.
Okay. You could drop anyone. Highest frequency, you could even drop it. Okay. So we could drop anyone. So it will not make any effect.
Okay.
Got it?
Mhm.
Suppose if we are having, I just write here, the 2.3, 2.3, okay, 2.3 I also write here somewhere, 2.3. So here it is 0, here also 0, here also 0, here it will 0, 0, 0, 0, 0, 1. And one more category which we have dropped, that is 3.7. So I am writing the 3.7, but we have dropped it. Okay. It is the drop, we have dropped this category, but I am showing you if
Okay.
there is 3.7, so it will 0, it will 0, it will 0, it will 0. It means it will go to the drop category, which are not mentioning here. We are not mentioning this. But if all 4 are 0, it will go to fifth one. Does that make sense to you? Okay.
Yeah.
So in this way, we convert this. What happened? Suppose you are multiplying this. So you will multiply 5 with minus 2. Whatever the you are doing. So 5 with you are multiplying the 5 with temperature. So 5 with the minus 2, then it is 1. Other are 0. And we multiply with minus 2 plus 0 plus 0 plus 0. We have the 4. So you will get the 5. Okay. In this way, we got the thing. Does it make sense? So one thing is that. But if you have the many unique values in the temperature, you have the temperature minus 3.2, then minus 3.1, then 2.7, then 2.1, then minus 2.3, then minus 1.5, then 0, then 1.2, then in this way you are getting so many unique values. Then how you will treat with this 0? So we make the class interval first. Okay, we make the class interval like I just give the hypothetically minus 15 to minus 5. Oh, sorry, minus 10. 5 का difference लेते हैं. Minus 10 to minus 5. Minus 5 to 0. 0 to 5. 5 to 10. Does that make sense to you?
Yeah.
Now we take the mid value. Okay, mid value we add these all both and we divide by 2. So it is minus 12.5. It is minus 7.5. It is minus 2.5. It is 2.5. It is 7.5. So you will see we always take the 0 in the upper and the lower limit. So you won't get 0 in the mid value. Does that make sense to you?
So my question here would be like, so after we are classifying it, why again we are going to mid value?
The class interval we have taken after this.
Sorry. Yeah, class interval.
So why we are doing? We want a single value. If you have to multiply, which how could you multiply any number with this?
Okay. Okay. Got it.
We want the single value, no? So we could take the in the further analysis.
Okay.
Okay. So here you won't get that zero. We have the problem with the pseudo zero only, na? So we have removed that pseudo zero from here. Got it?
Okay. Yeah.
So
Okay.
now we could multiply this thing or the divide these all numbers by any number. Okay.
Okay.
So this you have understand. About the pseudo and real. Real we don't have any problem. Now I explain you that where I have written that. We have ratio. So in the interval we have both zero, pseudo and real. Got it? But in ratio we have only real zero. Does that make sense to you?
Yeah.
So generally we say the interval scale. Somebody has used the SPSS. Have somebody used this tool?
No, we've not. I mean, I have not.
Okay. So it is the tool of IBM for the statistical analysis. When we upload the data in SPSS, it asks about the each variable. So there is three options which provide us: ordinal data, categorical data, and third one is the interval data. So it not explain, it not ask about the ratio data, because the in the interval you have the pseudo and real both. So don't go to the ratio. Okay, just be careful about the pseudo or the real. Okay, so for interval it says that the scale data. Scale data is the interval ratio both. So interval scale generally we use instead of real is ratio scale. Is it clear? The data classification.
Yes.
Yes.
Any doubt here? I will share the link also, recording link. So you could go through it. I will also share the PPT. I show you the PPT of that. I think it should be in this PPT or some other. I guess just a moment. Just a moment. And there is some slide I'm just forgetting where I could keep that. I will send you. I will send you that. The data classification is I have given over there. But in which slide I have included data, I will just see. Univariate, it is not showing me. It should be here, but it is not. Maybe in the chicken. इसमें नहीं है. इसमें हो सकता है. Just a moment, I just search it. Univariate, we are not getting univariate data visualization. It's not your data preparation. It may be in the data preparation. Types of data I have given somewhere. Don't know which slide it is. Okay, I will see where it is. It is somewhere in some chapter, I think. So I will share that sheet also on the PDF. Where I have explained the classifications of the data, various classifications of the data I have explained over here. But here in the session, I have explained the hybrid classification, which will not make you any confusion. Okay, so we are getting here the classifications of the data, then categorical data. We have seen the numeric data. We have seen the ordinal data, binary data. We have seen the scale data. In the scale data, we have seen the discrete and continuous. In the continuous, we have seen the interval and ratio data. Okay. So these are all we have seen over there. So this was all about the data. Now we talk about the measure of central tendency, which is the next topic. Measure of central tendency. You know that we have the measure of central tendency, mean, mode, median. There is mean, median, and mode. So why we take the central tendency? Can somebody tell me? What does it mean? It is we want a single value which represent the whole data. Like you see, the member of parliament represent our constituency in the parliament, national level, and MPs represent our constituency in the state level. In the city level, you see the parsad represents. Okay. So there's a single person represent you Similarly, in the data, we want a single value which represents the whole data. That is called a measure of central tendency. We have a different procedure by which we could measure the central tendency, the mean and median and mode. So we discuss about this. The first one is the mean. If we talk about the mean, it is an aggregate measure. It is an aggregate measure. Now we involve all the values when you find out the mean or the average of any number. You involve all the values, you add on all the values when divide by the total number. So it is an aggregate measure. But if we talk about the median, it is a partition measure. We arrange the data in ascending and descending order first, and then we divide the data in two parts from the middle. So it is a partition measure. Divide the data in two parts. Mode is the value of highest frequency. Data is called the mode. So it is the frequency measure. So got this thing? Does it make sense to you? Now, if I write a data like this, so if you find out the mean of this data, what would be the mean?
$25.
11.
What?
Mean is 11, right?
8.
No, I think I did an average. That's not me.
How much
Mean
the
is 11.
total? I think
10.
that
55,
16,
10.
30, 50. 50 divided by 5. So what would be the mean?
10.
10. Okay. And what would be the median? Median is the value of middlemost term.
8.
8. Got it? Now if I change this value, instead of 2, I write 4. The mean will change or not?
Mean will change.
Mean will change. The median?
Median
Media
won't
will
change.
not change. So these values are called the extremes. And these are called the extreme values. Understand? So mean is sensitive with extremes and median is not sensitive with extremes. If you change the extreme value, median will not affect it. Okay. So it is sensitive to extremes. Got it? And not sensitive to extremes. And mode is not sensitive to extremes. Why we are studying this thing? Because sometimes we get some outliers in the data. Do you know the outlier? Yes. Outliers, do you know?
totally different.
The value which is different from the most of the values of the data, which are, it is on the extreme side always, it is always on the lower side or the upper side and the extreme sides. So the values which are very different from the general value of the data, most of the values of the data are called the outliers, or we generally remove those outliers and we adjust the outliers. Sometimes we impute some other value instead of that outlier. So we do the capping and flooring. We will go later on that process when we learn about the data preparation. So at that moment, you change that value, extreme value. Just like we are putting, instead of 2, we are putting 4. And you have previously measured the mean of that data, and then you change the value of extreme. And by mistake, you are taking the previous mean in your further analysis, then it would be wrong because you have changed the data. Does that make sense to you? So you have to remeasure the mean, new mean, and then use in further analysis. But if you are taking the median as a central tendency, then there is no need to re-measure the median because median is not sensitive to extremes. Does that make sense to you? Got it?
Yes.
So that is the thing. We will go in deep later on. I'm not talking about the formula and this all. This all we will get in the R, or R itself. We write the command mean, it will give us the mean. Okay. But we are understanding what is the concept behind this measure of central tendency.
So again, there may be some possibility of mode. If the mode also can change if we are changing the extremes, right?
There is possibility. Is the mode is on the extreme value. The last basically we prefer the mode for the categorical data in the data analytics.
So, like if we have too many extremes, then mode will change, right, sir? But that will be considered as outlier as well, right?
Outliers as well. So mode is generally for the categorical data. So categorical data is not in the any arrangement. No, you could write the male first and you could write the female first.
Yeah.
Okay. So category like the hair color, we could write any color anywhere.
If you don't
Golden
mind,
first
can
and
you
this
explain
last.
the outliers again. I'm not understanding the outliers concept.
Okay. Suppose you have seen the movie Kabir Singh.
I have not,
No.
but you can go on.
Yes.
So the range of audience, age range of the audience, what should be for the like the movie like Kabir Singh?
Assuming youngsters,
Youngsters from 18 to
yeah, 25 or 30 maximum.
we take a big range. Suppose we take up to 50, 18
Okay.
to 50 years.
Okay.
Okay. आप हमें कैटेगरी से बाहर नहीं निकालें. So that is the range of watching this sort of movie. And a person whose age is 80 years, and we got the data, he was also in the multiplex or the theater where the Kabir Singh was running. But he was actually there. The 80-year-old person was actually there. So this is an outlier because this is the extreme case. Because the person had came from the village for repairing his submersible pump, and it was a very hot day. So he asked to the shopkeeper how many time you will take to repair it. So he told him 4 to 5 hours. So where he will spend his time. So he asked him, it's very hot day. So he told him, you go in the talkage and sit over there for 3 hours. You watch any movie. He just seen over there. Okay, well, you don't know. He went over there and slept in the theater or in the multiplex. But the age of 80 years in your data now. So if you do the analysis including that 80 years, it will mislead your result or not? Yes.
Yes.
So that is the outlier. Your data is in the range of 18 to 50, but there is some data points are very different. They are called the outliers. Understand now outliers?
Okay.
Okay. We have some formula in data analytics by which we could set the critical limit for the outliers. Okay.
Okay.
Beyond that, the value would be outliers, and below that, the value would be outliers. Okay. So both limits it set through some formula.
Okay.
We will discuss later on that formula. Okay. Understand?
Yeah,
So
yeah.
don't bother about what would be the outlier, what would not be the outlier.
So I was
Okay.
just trying to understand the concept of the outliers here. Yeah.
Okay. So
Fine.
that concept now clear?
Yes. Got it. Thank you.
Now, if we talk about the mean, we always get a unique mean. Can you get the two mean of a data? You always get the one and only one mean.
Yeah.
So it is always unique. Median will always be unique. One median you will get. You will not get the two median out of a data. But mode, it may be more than one. Maybe more than one. It may be bimodal. It is called sometimes the bimodal data, trimodal data. Suppose we are having few numbers 12, 14, 16, 18, 20, 22, or we are getting the frequency of 12 marks is out of 25. It is 10. Frequency of 14 marks is 6. This is 2. This is 4. This is 10. This is 8. So highest frequency we are having 12 and 20 both 10 frequency. Got it? Getting it? So
Yeah.
this is the bimodal. Mod is what? The value having the highest frequency. So 12 is mod and 20 is mod. Both are mod here. Got it?
Yeah. Mhm.
So maybe more than one. Mod may be more than one. Okay, but the median will always be unique.
Yeah.
One and only one. Median
Yeah.
will always be unique. One and only one. Does that make sense to you?
Yes.
So this was all about the measure of center tendency. We don't go beyond it. We don't go in the formula side. We just understand mean is aggregate measure. Mean is very sensitive to extremes. Mean has always unique. Okay. In the median part, we have to understand that it is a partition measure. We arrange the data in ascending or descending order. Then we partition the data in two parts from the middle. That middle value is called the median. It is not sensitive to extremes. It is always unique. Mod is a frequency measure. The highest frequency value is called the mod. Not sensitive to extremes. Maybe more than one. Okay. So this is all about the measure of center tendency. In the next section, day after tomorrow, we will study what the measure of dispersion. And in the same way, we don't go beyond the formula. There is no mathematics we have to study at all. Okay, this we will do already in the R. There are the formulas, everything. You just have to type the index SD and you write the variable name, you will get the standard deviation. You will get the mean, you will get the mode, median, everything you will get over there in the R or the Python, both. Okay, so we have to understand the concept. The day by day, the concept will make the deep space in your mind, but it will take little time because it will be repeated again and again somewhere in some other context. You will use it, so then it will make its position. So I think now, is there any doubt, any query?
बहुत सारे हैं सर, समझने में टाइम लगेगा थोड़ा।
टाइम लगेगा, पर आज आपने देखा जो आपने स्टैटिस्टिक्स अभी तक पढ़ा और आज जो आपने स्टैटिस्टिक्स पढ़ा वो एक अलग थोड़ा सा जो था उसको समझने का तरीका, उसको मतलब ये डिफरेंट चीज आपने पढ़ा होगा। आपने पढ़ा स्टैटिस्टिक्स पहले, ठीक है, पर ये जो चीजें हैं, जो स्टैटिस्टिक्स की जो इनसाइट्स हैं, ये इंपॉर्टेंट होती हैं डेटा एनालिटिक्स में।
सर कुछ रीडिंग मटेरियल है जो हम पढ़ सकते
हाँ,
हैं?
मैं भेज रहा हूँ आज भी आपको। ड्राइव का लिंक मैं भेज दूंगा ग्रुप पे, है ना। और आप लोगों के मेल आईडी आप लोग ग्रुप पे टाइप कर दीजिएगा सब अपने अपने। वैसे तो वो जिनका पेमेंट आता जा रहा है उनका मेल आईडी आ ही रहा है मुझे उस पे, तो मैं उस मेल आईडी को ड्राइव जो है शेयर कर दूंगा, तो आप वहां से डेटा पूरा, मतलब जो मटेरियल, स्टडी मटेरियल और आपका ये रिकॉर्डिंग लिंक वगैरह सब आपको मिल जाएगा आज दोपहर तक, ठीक है।
ठीक है,
ओके, तो वाइंड अप करें सेशन आज का।
सर एक और क्वेश्चन, पेमेंट कैसे करना है?
पेमेंट के लिए मैंने वो ग्रुप पे एक लिंक भेजा है आपको फॉर्म का, देखा आपने?
शायद मिस हो गया।
जीपे है
ना, तो
तभी आई विल सेंड यू द जीपे।
ठीक है,
तो आप
Transfer directly on your account.
हैं?
I transfer directly on your account, bank account.
Okay, you have sent. I could not understand what you are telling, sir.
So bank मैंने Gmail मतलब Google पे से नहीं किया, directly पे किया है आपको account में।
अच्छा, अकाउंट पे किया है आपने?
हाँ।
So okay, it will, I will get it. I will confirm you all. Okay, don't worry. I will confirm you. Because if it is account pay, then it will come later on after 10 or something, I think, or it may come the same time also. Let's see. Sangeeta's.
So IMPS किया तो I think.
Okay, just a minute. I just check here. IMPS you have done, na?
Yes.
Yes, I have got it. Sangeeta, yes, I have got it. Okay, so thanks everyone. I will share all the material by 12 today. Okay, by afternoon. I will send you lots of stuffs and you could go through it. And day after tomorrow, we will learn about the measure of dispersion in the correlation analysis and little bit about the regression analysis concepts. And then we start with R, and with we learn the basic functions of the R first. Okay, and then I will start the daily assignment to you, and you have to do some practice in the next day. or the same day, whatever, if you get the time, and take little time up to the 15 days. 15 days it will take to make a pace for this. So don't worry. Don't fear about it. You will do it better. After 15 days, you will be more confident. Okay.
Sure, sir.
Okay. So thanks everyone.
Thank you, sir.
Okay.
Okay,
Have
sir.
a nice day.
Same to you.
Okay.